To be training a model, and it's going to follow the same steps, just a bit different. Import CV2, import numpy as np. Then we're going to import our OS. Okay, that's all for now. Then we're going to define our detector now. Our detector, that's our cascade part, remember. CV2 cascade classifier. So we're going to store and put the file name for the cascade underscore frontal face underscore alt.xml. Then recognizer equal to CV2. Now we made the detector, we use it for, it's the same thing as this cascade part, I just changed the name. This recognizer is what we are going to use, and we have many of them, many algorithms. We have basic face recognizer, eigenface, facial face. We are going to use local binary pattern histogram. So from the library we are bringing out face. From that face we are bringing out local binary pattern histogram face recognizer underscore create. Then we have to define our path, the path for the dataset folder, so we can source it. So the next step is to define a function that will actually travel and walk down our dataset, get all these files and manipulate them for training. So def, let's give it any name, because we're going to call, no matter the name we give it, we're going to call it later. So image and labels, right? Where we want to get the pictures, the images, and the labels So let's pass in the parameter that we are going to be using when we call this function. So the next step, alright, so that reminds us, the next step is we have to import our pillow. There's something from pillow we have to import, so we are going to say from pillow, right? That's PIL, import image, and for this you have to install this with your pip. Let me just show you that. Windows key plus arrow, then administrative mode, Control Shift Enter. So pip install pillow. Requirement already satisfied, but yours is going to install, right? So let's continue. So get image from there. Then we want to now get the image part. Now we are trying to travel and walk down this data set and all these files and get all these files. So we're going to say image parts. That's a variable. What do we want to do? We want to walk down that. So we're going to say OS, right? OS, we're dealing with the parts. OS parts. Now okay. OS part join part comma. We want to join this part is not the same with this. Alright, we want to join this part, that is this data set with something that is f, right? We want to join all these labels with this data set, so it can look like data set / user .1.1 JPEG. So, but what is f? We are going to define that now. Join path, f for f in these paths, that we are going to say OS list directories. Now for OS dot list directory of this path. So this is the directory data set. It's going to list the directories in this data set. So that's it now. Path. So for f in these, so this f now, it refers to all these user 1 2 3 4 5. So the aim is for it to walk down and join this main path data set with this. So by the time we are done with that image part, we are now going to convert this to pillow to grayscale. So we say pillow underscore image, and we are going to say, because we are going to convert this to pillow image, then after that we are going to get a numpy image as well. Yeah, so in doing that, because converting to pillow, then numpy arrays of images. Remember, from here we got to join the directory with all with the subdirectories, and we stored everything in paths. So we want to now access everything inside these image paths. And to access everything inside image paths, we are going to say, because we have to do that first, we have to first access everything before we can convert, before we can use all those things. So we say for image path, look at it, it's without s, in image paths, so we have to take this ones inside. Alright, in image path, then we have to use this pillow library. Image dot open. What are we opening? We want to open each of these files, this list of directories. Image dot open image path, not paths, because this one refers to everything inside this. This should have s. This refers to everything inside this, right? So this for each of them is talking about. So by the time we open, we should convert to grayscale. How do we do that? We say L. Then for this, for numpy, as you know already, we are going to say np. Remember, it was numpy as np, it's short form. Np array. It should put this thing inside this numpy array. So what is it acting on? This pillow image, right? So this pillow image so we have to get our integer type, that is u integers 8, yeah, for data type. Then after that, we can now go ahead defining our empty strings, because we have to work down all these, because we've opened it and turned it to grayscale already, each of these files. Then we've converted each of these files from that are in grayscale to numpy array. So we have to open another empty string, because we are going to be needing it to store the faces and the identities. Our aim is actually to detect a face, recognize that face, and predict the name of that face along with the confidence percentage level, along with the names and the faces. So we have to get the face and we have to get the ID here. The confidence will come inside this later. So to continue, now we are now going to split, because getting everything like this, we have to, because now we have these two empty strings and they are still joined together, and we just want to get our images to one side and our labels to one side. So we have to split it, and so we are going to say integer, then OS part dot, what are we calling from OS part? We are calling split. What are we splitting? We are splitting this image part. This image part refers to everything inside the image parts. So we are splitting this image part before, then dot split again. Then this time around we are going to say after. But mind you, what we are splitting exactly will now be something here, and this is our dot. Everywhere we have this dot, we want to separate them. We want to separate the labels from the image. So we are saying split this part, split everything here, these all directories, target where these dots are, split them, before and after, split them. So that's what we've done now. So now that they've been successfully separated, then we can now move on, because we can now append everything here now to our ID, then append to our face samples. So in doing that now, after this stage, we're going to come here again to store it in an ID variable. So let's go again, and this time we're going to say, you can see everything is in a function. We're going to say face samples on faces equal to, let's call our detector now, because by the time after traveling down everything here, we should now call our detector now. we need our detector to detect each of these images before we can now start appending to this and this. So detector, remember detector dot what? Our normal stuff. So detector dot detect multi-scale of what exactly? Of this image numpy. Alright, you can put your mean neighbors and everything, but we're going to leave that out in this video. Then we're going to move on to say, just like the way we do for rectangle normally. So for x, y, w, h, in faces, from this detection, get these four corners. Then there's a column there, remember. Then we can now start to append. So I'm going to say face sample equal face sample dot append. What are we appending? Image numpy, right? Image numpy. Then this image numpy, we have to specify and update our x and our y values. X column, then map x w, then y plus h. Alright, then for our ID, let's give these IDs because it's holding many IDs. Let's give these samples because it's holding many samples. Then for IDs, we have to, now this is going to split the directory. So we want to just get the label there. That's just what we want. We just want to get the labels. Then let's store it in ID. So these IDs, let's append. Appending is just a word meaning to attach. Just add to it, to attach, to add. So append, what are you appending? This ID, right? You are appending ID into IDs. You are appending these into face samples. But before we do that, we have to put it in an array ID. Alright, so at this point we can now return our values. We're still in the for loop, so let's break out of that. We can now return our values and we can now say return face samples and what? IDs. So at this point we can now call our function. We can now say faces, then IDs. Let's call this function now image and label. Let's pass in our part, that dataset directory. So by the time we do this, it's going to run this whole function. The code we get here, because the code we just read all this, but it won't implement this function yet because it's not yet called up. By the time the code starts getting to this place, it's going to it's going to run this function, then return our values in faces, and image, then we'll get our IDs. So at this point we can now train. So we're going to say recognizer. Remember we defined recognizer earlier. Recognizer, then call train from it. What are you training? You are training faces, and you are training your IDs. We're also going to put this in NumPy array. Alright. Okay, let's just append this ID normally. Just append this ID to IDs. Then we can just put it in an array here. Yes, IDs. So this will train our work. Then after the training, we can now save this work. That's recognizer. In this one, you don't say in right now, you just say write. What are you writing? We have to define the part. Write it. Okay, save it to. Now we have to define. We have to create another directory here, because we are going to need that directory to store our trained files, because this is going to train the file, then store it in a particular format. So we have to create another directory for us to store it in. So let's say make directory trainer. So it's going to write into our trainer folder / trainer.yml. This is the format. Means it's going to get to this trainer folder, then create this file for us. Then at the end, we can now print done in our console just to show us it's done. Done with training. So let's run. And correct any error we might have. Python trainer.py. Okay, we're still in that function. Okay, let us leave this function. We're still under the functions indent. Alright, so let's try it now. Okay, name, there's an error here. We call this faces. Okay, we say for X, Y, W, H in face instead of faces, right? what it detects, in the face it detects, store it in faces. Then now get the four corners of those faces. That's what we're saying. Trying it again. Okay, another error. 35, line 35. What do we have there? You will need more than one sample to learn a model. Alright, this happens sometimes when your model is not too clear. Sometimes it happens when your data are not too. You need more than one sample, more than one good samples to learn a model. So we're going to come back here again, but I will just add. You can just add a random clear picture of your